In this episode, we learn how to destroy the Earth. If we can compress it to the size of a marble with a diameter of 1 centimeter, it will become a black hole, and it will be utterly destroyed. Here's what that might look like. This is a clip from the most recent Star Trek movie, where the evil Captain Nero implants red matter in the center of the planet Vulcan, Spock's homeworld, turning it into a black hole. Now, no one's sure exactly how red matter works, but as you can see, the planet does get quite small. Alright, so what the heck is a black hole? Well, it's ultra-dense matter. Nothing can escape it, and that's why it's called a hole, because if you fall in, you can't get out. And not even light can escape it, which is why it's black. So whatever it is that it looks like, we'll never know. No one's ever seen what's in there, because light can't come out and tell us what it is. Well, no one really knows, but some ideas that have come up, it could be what's known as a singularity, an infinitely small place in space, a point, if you will, with an infinite density. It could be a door to another universe. In fact, the universe we live in could be a black hole. We could be living inside one. There's really no definitive evidence on that question. It's just a crazy idea that some astronomers have had. Turns out that there are lots of black holes out there, and there's a humongous one in the center of our galaxy. In fact, in the center of most galaxies, there are what's called supermassive black holes. Here's a picture of a beautiful spiral galaxy. It's thought that our galaxy looks something like this from far away. And in the middle there, where all that bright, warm, golden light is coming from, right in the middle, it's thought that there's a black hole of several million times the mass of the Sun. And it's thought that all galaxies have something like that, or most of them. Well, Mr. Albert Einstein gives us some insight into what would happen if we fell into a black hole. According to Einstein's theory of general relativity, mass bends space and time. And this bent space and time tells mass how to move. And next to a black hole, space and time are bent so much that there's this tremendous hole that nothing can get out of, and time actually stops at the edge of a black hole, what's known as the event horizon. So if you fell into a black hole, I'd see you stuck at that event horizon forever. You, on the other hand, would not experience that. You would pass right through. And on your way through, you would be stretched by the differential gravitational effects and compressed. So you would be turned into a long string of spaghetti. Would you survive? Would you pass into a wormhole? Nobody knows. A wormhole gets this name from the idea that if a worm chews its way into a book of maps, it could chew from one page to the next, and if you unfolded the map, it would look as though the worm went from one place, place A, to a very distant place on a different part of the world, place B. So a wormhole is a theoretically possible thing that could connect distant places in space and time, but no one's ever seen one or has any idea how to make one. Anyway, someday if we figure out how to go into a wormhole and survive the trip, it could be the answer to traveling faster than light, great distances in space as well as to travel in time. It could be also that going into a black hole leads you into another universe. In the movie Star Trek, these people travel into a black hole and it helps them to travel back in time. In reality, with our technology the way it is now, we would not survive the trip. We would be destroyed, we would be stretched and compressed, and it would be a painful and terrible death. So, steer clear of black holes and you'll be alright. So now we need to talk about different things that can happen when a star dies. Different stars die in different ways, leaving behind different kinds of remnants, or leftovers. If a small star dies, it just leaves behind a boring, cool red dwarf. Nothing special, the star just runs out of gas and slowly cools off. A middle-mass star like our Sun, when it dies, as we've discussed, it will form a planetary nebula, ejecting its envelope into space, and leaving behind a hot white dwarf from its core. Here's what that looks like. This beautiful thing is what's known as the Ring Nebula. From far away, it looks almost like a planet. It's round, but if we get this nice zoomed-in view, we can see that it's really a beautiful cloud of gas and dust. That tiny little white dot in the middle is thought to be the white dwarf that's the core of the leftover star. When our Sun dies, it could very well make something beautiful like this. All that beautiful nebulosity around the white dwarf is what's left of its envelope that was ejected when this star died. Unfortunately, any planets that might have been circling this star would have been devastated by this hot plasma as it rushed past them. But it is beautiful from far away, and the pictures of planetary nebulae are some of the most beautiful in astronomy. Let me show you a few more. Wow, it's thought that the complicated patterns here result from the spinning of the white dwarf. Here's another one with a crazy pattern, and again, the symmetry is thought to revolve around the spinning. Okay, well, what about a higher mass star? Well, as we talked about, higher mass stars go through different stages of fusion, fusing hydrogen, then helium, then carbon, etc., all the way up to iron, after which they can no longer support themselves through fusion, and a supernova will ensue. Right? A supernova is a colossal explosion, leaving behind, in many cases, what's called a neutron star. A neutron star is made up of all neutrons. It's like a giant nucleus. To compare to a white dwarf is made up of normal atoms. And if an atom is the size of a giant soccer stadium, the nucleus is the size of a marble in the middle of the soccer stadium. Okay, so if you imagine taking a star and compressing it down from the size of a soccer stadium to the size of a marble, that's how dense a neutron star is. A cubic centimeter of neutron star material contains the same mass as all people on Earth combined, whereas a cubic centimeter of neutron star material is equivalent to a car. In both a white dwarf and a neutron star, the matter has very strange properties that we're not used to. One of the strangest things is that the bigger it gets, the smaller it gets. The compressional forces of gravity become so intense that as you add matter to these things, they actually get smaller. A smaller white dwarf is actually more massive than a larger white dwarf. And the same goes with a neutron star. Weird stuff. Here's what a massive star might look like near the end of its life. You can see the different layers of elements that have been created in the different phases of fusion, with the iron core represented by the letters Fe in the center. This is a massive star near the end of its life. And here's what would happen next. Boom! This is an image of a supernova remnant. This thing exploded hundreds to thousands of years ago, and we're looking at what's left in X-rays. Huge cloud of expanding gas. Here's another one that's older. You can see that the gas cloud has been torn apart, and we're seeing just the last shreds of this stuff. Again, it's beautiful, but you wouldn't have wanted to be anywhere near it, within 10 light years of it, or you would have been destroyed by the explosion. A supernova is able to emit the power of an entire galaxy. This is a picture of the neutron star at the center of the Crab Nebula. At the very, very center, the small little white dot there, that's the neutron star. It's ejecting a jet of gas out each end, and it has a torus, or a donut of gas and debris circling it, crashing down in on it. And this thing is a pulsar, meaning that if we look at it from our point of view, it emits radio signals in a very regular pattern, like a clock. In fact, it's more accurate than any clock on Earth. And scientists have done a lot to study this particular pulsar. So this was the result of a supernova hundreds of years ago. It left over a neutron star. Now, if you put a neutron star too close to another star, a normal star, it can actually eat that star. And this is a picture, an illustration of what that might look like. The gravity around a neutron star is so great that it actually could suck gas off of the surface of another star and bring it down onto itself, thereby growing in mass. And if the neutron star gets big enough, it can turn into a black hole. And that causes another kind of supernova. So we need to look at black holes again. So what exactly is a black hole, and what does it look like? Well, as I said, it has infinite density and no size at all. It's impossibly small. How do we see it if it's so black and small? Well, stuff falls onto it. If anything gets near it, it's going to fall onto it. And when it does, it makes lots of energy released. And some of that energy will be trapped in the black hole, but not all of it. And often a lot of energy is released in the form of powerful X-rays. Also, we can tell a black hole is there by the way it pulls on nearby stars. Let me show you what I mean by all this. Here's a picture of what a black hole might look like. The black hole is invisible and tiny in the center of all this. But all the stuff that's swirling around it and smashing into other stuff is making tons and tons of light. And so we're able to detect this kind of object by all the violent ejection of gas and collision of matter around this thing. And like I said, these things are usually best seen in the X-ray region of the electromagnetic spectrum. That's one reason that we look at X-rays from space. This is an awesome video of actual real data that was taken from stars near the center of our galaxy over the course of 15 years, I think. You can see how the stars in the middle are moving quite fast. And it's thought that the thing that's pulling on them is the supermassive, million solar mass black hole at the center of our galaxy. Just amazing. Just very powerful evidence that there's something very horribly large and powerful lurking in the dark there.